Okay, question 5 part 1 is an modulus inequalities question. Now, there's a couple of ways you can solve this type of question. I always solve this with a graph. So I've already set up a bit of squared paper down here and drawn some axes on there. So two things to do first. Let's draw both of these lines. This one's a bit easier, so I'm going to draw the x take away 3 first. X take away 3 has a positive gradient, would go through -3 down here on the x-axis with a gradient of 1, so it's going to go up 1, up 1, up 1 until it gets to 3. But because it's a modulus, not just the normal graph, when it gets to 3, I know it goes off the page here, but that doesn't really matter, it's going to go back up rather than carry on going down. So it's going to hit +3 on the y-axis. And it's important to write down in what these two individual lines are. So this is normal y equals x take away 3. But this is y equals minus x plus 3 because we reflected it in the x-axis. So my next job is to draw the 2x plus 1 line. And 2x plus 1, again, has a gradient of 2, crosses the y-axis at 1. So it's going to look something like this. It's going to carry on going down, but when it gets to the y-axis, which is happening at -1/2, it's going to go back up again. And they don't quite meet on my graph. Let's just move everything. Let's cheat and just move this. Oh, that's not going to work because I've not. Just want to move this up a bit so we can see where they meet. Hopefully this will work now, that we can see roughly where they meet. Now, we're going to go ahead and solve this algebraically anyway, but I think it's always a nice thing to see the points of intersection if we possibly can, because when we've done the algebraic method, we can then kind of say whether our answer is accurate or not. These two blue lines, though, this one's y equals, the normal, y equals 2x plus 1, but this one here is y equals minus 2x. -1 now, again because of it's the reflection of the line because of the modulus. So how do we find where these two lines intersect, or where these two sets of lines intersect? Well, this intersection point comes from when 2x plus 1 meets the -x plus 3 line, and if we solve that by adding an x on, that's going to give me 3x equals 2, so x is 2/3, and that roughly looks about right, just between 1/2 and 1 somewhere. So I'm happy with that. And this second point here comes from when minus x plus 3 meets minus 2x minus 1. So if I add these two x's on, that gives me an x. Take away the 3, that gives me x equals -4. And again, because I drew it nice and accurately, we can see that that -4 is bang on correct. So, what do we know now? Well, let's get rid of this extra writing, because that's a little bit in the way. These 2 points here are the 2 intersection points. And the question says, when is the modulus of 2x plus 1 less than the modulus of x take away 3? When is the blue line lower, smaller than the green line? And because we've drawn it really visually, really accurately, we can see that it wants to know when the blue line is below the green line, and that's therefore between the 2 points of intersection. So my answer is that the blue line is lower than the green line. Is it equal to? Yeah, it's an equal to question. So I need to put my or equal to lines in between -4 and 2/3.